One of the last blogs I wrote, I commented about the ability for Tetration now to ingest telemetry from a client that had AnyConnect installed. Essentially, there's a module called NVM Network Visibility Module. And in that last blog, we talked about a series of questions that customers have often asked. Hey, how can you help me solve these particular questions here? So what I'm going to do today is take you through a live demonstration on how we're now helping customers with tetration and now taking telemetry from AnyConnect NVM to start helping get these questions answered. What we're looking at is a tetration instance running software release 3.1. Under the software agent tab, we have a collection of all the different tetration native sensors, or now AnyConnect NVM instances that are registered with this cluster. So just as an example, we can see some Mac OS instances leveraging the AnyConnect client. We've got Windows 7, Windows 10. We can even have mobile devices with the supported operating system. Now, what I want to do is start to drill down to show you more about the information that we collect with NVM. So I've asked Tetration, pull up this particular IP address. And at this time dimension, this is the information we were able to grab. Because remember, IP addresses can be released and another end user, another device can pick it up. But right now, this IP address is a Windows instance. It checked in at this last time dimension. And we can drill down even further. We can see that it does have two interfaces. And there are user annotations that Tetration has been able to grab from either LDAP or Active Directory. Again, at this time dimension, I own that IP. There's my user ID. And this is the LDAP or Active Directory group that I belong to as an end user. But again, keep in mind, these annotations are all time series based. Now, we can drill down even further now. So again, looking about over the last 24 hours, we can see the total traffic volume from that Windows 7. And then we can also take a look and see what we've captured as it relates to what are the long-lived processes that are running on that Windows 7 machine. We can see the username that was used to launch the process, what's the process binary hash, which we also go out and compare with VirusTotal to identify if it's something benign or something malicious that we need to get cleaned up. And we also understand what was the process command line argument that was used to launch that process. Now with that, what we also do is we record the entire process lineage of that instance as well. So we understand from a forensics perspective what was a parent process and what are different child processes that might have spawned off of the original parent process. And then lastly, we also grab, again, over the last 24 hours, based on my time query search, what were the domains that I visited? How much data have I sent? How much data have I received? And also, what were the DNS resolvers that I was using? But also keep in mind, all of this data can be anonymized as well. What we're looking at is inventory filters. This gives me the capability to define predefined filters or groups of endpoints that match on a particular query. So as an example, we have a filter called Tetration Engineering, and it's basically looking within Tetration, and it says find all IP addresses or subnets that match on this particular query. Anything that belongs to this LDAP group called Tetration Engineering. And if we click on this, it'll pull up again what IPs right now that match on this. And if we go back, there's another smaller group. This is a group that I belong to, and it pulls in the IP addresses that I'm using on my test VMs. Now keep in mind, again, this is purely time-based. So any IP that might belong to this group that might be released and picked up by another employee, another end user that might belong to a different Active Directory or LDAP group. We're looking at flow search. What this provides me is the ability to have DVR-like functionality that allows me to go back in time and replay any of the flow data and contextual information about the endpoints within that flow and replay them. So since we're focused on clients and client endpoints in this demonstration, let me focus on pulling up how do I know all the IP addresses that I might have used over the last couple of days. So we're just simply asking Tetration, pull up all flows from the end user JG emitter. And again, since September 13th, I've had 3 different IP addresses over those last couple of days, and I've pulled up almost 13,000 flows over that time period. Well, we can also drill down further and understand what were the processes that I was using to access applications, whether or not it was within our data centers or I was going out to the internet or public cloud to grab information. So these are the processes that were involved with these flows. And then I can drill down even further and get a better understanding of what were the URLs that I was visiting while leveraging that instance on my laptop. Now, what I also want to show here is I have another test web server. And if I'm an IT administrator and I want to understand who is exactly accessing this Ubuntu instance, yes, Jason's accessed it twice with 2 different IP addresses. I can drill down even further and understand I was using Chrome to access it, as well as a PuTTY instance to SSH to it as well. Then I can drill down again even further and understand, yep, that was me coming from this particular LDAP directory group. What we're currently looking at is an Ubuntu VM running Apache. Right now, our IP tables are empty except for the golden rules that allow Tetration sensor to communicate with the cluster. And our IP set list is also empty except for the rules that allow communication to the Tetration cluster. Now, what I want to show you is here's my test VM, and we can hit that web server, and we also can hit it on SSH as well. Beautiful. Now, what I also want to show you is here's AnyConnect NVM running on this Windows 7 VM. I don't have a VPN running. There's no requirement for the VPN to be running. It just needs to be connected to a trusted network, whether or not it's a campus, branch, wireless, but it tells the AnyConnect client I'm trusted and stream the NVM telemetry to the Tetration cluster, and here is currently my IP address. Now, what we want to use Tetration for is to define intent, a zero trust model that defines who's allowed to communicate with this web server. So let's start with that predefined inventory filter we created earlier, Jason's web server, and let's define the Active Directory group I belong to. You can hit this, or I can hit this web server on port 22. I'll add another rule that says anyone from Tetration Engineering can also hit this web server, but on port 80. Now, if we take a look at this, what this is our zero trust policy. Now, any flow that doesn't match these 2 rules will then match on the implicit deny, catch all and deny. So as we kick things off, we're going to kick off policy analysis. Now, what policy analysis does is before I want to hit the enforce button, I want to know the impact of if I were to push these rules out to this web server, what would happen? What flows would have been denied? What flows would have been permitted? So I know with a high degree of confidence that my rules aren't going to break anything. Now, we've gone into the future a little bit, basically just sped it up a couple of minutes. And these are the results of the policy analysis. Now, I've ran back on my Windows 7 VM. I generated some traffic, and I did try to access that web server on port 22. And it did show me, yeah, this would have been a flow that would have been permitted. These are the rules it would have matched on, and this is fantastic. It's the consumer outbound policy that says, yes, anyone part of this group can communicate with that web server on port 22, as well as the web server saying, yes, anyone from this group can communicate with me. So again, if you think back, the way we do enforcement, we can enforce at the Ubuntu instance, or we can publish that policy for someone to enforce in the infrastructure. We get the bidirectional rule enforcement. But what we also grab here is we understand, the TCP flags in each direction. The flow was open for almost 5 seconds, what application latency looked like at a very high level. And then we also understand that it was my PuTTY client on my Windows 7 VM. Now, what would have been denied? And this is when we kicked off that or started to simulate that policy. So if we look here, I also tried to access that web server on port 80. And again, this was just policy analysis. This is telling me that this flow would have been denied. We did not have a policy defined that whitelisted this communication. But again, this was purely for policy simulation. So it allows me to further understand when I'm ready to enforce, I'll know what the impact is. So from now, I think I'm pretty comfortable with this. Let's go and enforce this policy. So we hit the enforce button. And now what's taking place is Tetration is dynamically computing these rules for the individual sensors that are installed that support that web server, as well as publishing this policy to a Kafka bus for any third-party appliance that is interested in taking that policy off the bus, normalizing it into their language, and enforcing in the infrastructure. Now, if we run over to this Ubuntu instance, let's take a look and see our rules are here. There they are. Here's our IP sets and permitting web traffic, SSH traffic, and we can take a look at our IP set list as well. So here's my IP set that includes my 2 IP addresses from my Active Directory group. Now, if we jump back and we go to that Windows VM, now on that Windows VM, let's see if we are able to communicate with the web server. And that's being denied, rightfully so. It was not part of the Zero Trust policy. And SSH was. And I am able to access the web server accordingly. Now, what we would have here, as telemetry streams in, we would know that with this policy being enforced, these are the rules being permitted. These are the rules that are being, or the flows being rejected. These are the flows that are escaping. Something's changed in the infrastructure that's allowing things to communicate that shouldn't be allowed. And we'll show you one last thing, is if we jump back over to this web server, not only did I show you the rules on the endpoint, but these are the rules, the concrete rules that have also been pushed down to that web server. So we see them with the IP set command, IP table command, and now we get an understanding of all the 14 concrete policies. And again, the policies are representing 3 different IP addresses that were on that web server. So these are all of my permit on the ingress and ingress side, and then my implicit deny all the way down at the bottom. Now, to summarize, I wanted to come back to those original questions that we want to help customers get answered. Who is accessing my application? What group does he or she belong to? What device type are they using? What process are they using to access those applications? What is the Zero Trust policy that we want to define and enforce at the workloads in the data center, or making that policy available for infrastructure to take it off the Kafka message bus and enforce within the infrastructure, and define a true Zero Trust policy for what in the campus, branch, VPN users are allowed to access within the data center. And then from a day 2 support perspective, getting a better understanding of network performance, contextual information about how those flows are performing, and then getting that very high level indicator around what application latency looks like, which becomes a great opportunity where we might see high application latency to get something like App Dynamics installed to understand why application latency might be high. If there's any questions, please feel free to reach out to me on my LinkedIn profile. Thank you.